Today I want to look at lesson number 3 on rational expressions and equations, which is addition and subtraction of rational expressions. So as I talked about last week, rational expressions are like a fraction. So if we recall our rules for adding and subtracting rational numbers, we can extend those to rational equations. So to add and subtract rational numbers, we have to determine the lowest common denominator between our two. There's two ways that we can do that. The easiest way that you can determine a common denominator is to multiply the two denominators together. The other method involves whether or not the one denominator is a factor of the other one, such as 8 and 4. 4 is a factor of 8, so I could use 8 as my common denominator. Whereas before, when we were looking at rational numbers, a common denominator, didn't matter which one it was, worked. When we're dealing with rational expressions, we would like to keep it as the lowest common denominator. It'll be less simplifying at the end if we actually keep it as the lowest common denominator. Once you have your lowest common denominator, you then write each rational number as an equivalent rational number using that common denominator, and then add and subtract the numerators as indicated. Then reduce if possible. So if we look at these rational numbers, if I have 2/3 and I'm adding it to 2/5, what would my common denominator be? 15. So I would have to rewrite both fractions with a denominator of 15. So 2/3 is how many 15ths? And 2/5 is how many 15ths? 6. So because the 15 is the same, if I want to, I could write it over one denominator, just 10 plus 16 over 15. And what is 10 plus 15, or 10 plus 6? 16. At this point, I do not need to change this into a mixed number. I can leave it as an improper fraction. I just want to double check that I don't, or that I can't divide 16 and 15 by a common denominator. Okay? So I'm going to give you a couple of minutes. I want you to do questions B and C. So what's my common denominator for B? 12. Okay? So I could write it just all over 12 and then just do the tops one at a time. So 5/6 would be how many 12ths? 10. And 1/4? So 10 minus 3? 7/12. If I had used 24ths, multiplying the two denominators together, it still would have worked, but I would have had to reduce my fraction because I would have ended up getting 14 24ths. Okay? What's my common denominator for C? 24. So I could write everything over 24. And then 7/8 would become 21. 2/3, 16, and 5/12. So 21 minus 16 plus 10? 15. Can I reduce 15 24ths? Yeah. What's 5/8? I can divide them both by 3. So that was kind of a tricky one because it's hidden in there. So the method for adding and subtracting rational expressions is the same as rational numbers. So we deal with common denominators. So the first thing that we're going to look at is we're going to look at having monomials, rational expressions only in the numerator. So our denominators are going to remain just whole numbers. So if I look at A, what would my common denominator be for 4, 5, and 10? 20. So I could write everything over 20. in order to go from 4 to 20, I would have to multiply by 5. So if I multiply 3x by 5, I would get 15x. And I don't need to show that 3x times 5 because I can do that as mental math. So if I take 5 to 20, I'd have to multiply by 4. So if I multiply the numerator by 4, I would get. And then my 10 to 20 would be to multiply by 2. So what would I multiply 7x by? 2. And I would get 14. So then I have 15x plus 4x minus 10 or minus 14x. What would that leave me with? 5x. So I get 5x over 20. Now look at the two numbers. Is there a common factor for 5 and 20? 5. So if I divide them both by 5, on the top I'd be left with a 1x or just x. And on the bottom, 4. So if I look at B, what is my common denominator for B? 6. So I'm going to write everything over 6. So what do I multiply 3 by to get to 6? 2. So I'm going to multiply the top by 2. This time I'm going to actually write it out because the top is an expression. It's just not just a monomial. And the second fraction, or the second rational expression, doesn't change because the denominator is a 6. So that 4a plus 5 would stay the way that it is. And because I'm adding, I don't even need to put brackets around this 4a plus 5. So now remove the brackets or multiply this by 2. And my last step would be to collect my like terms. So 6a plus 4a. And negative 2 plus 5. Can I reduce that? So in order to reduce it, I have to be able to divide each term by the same factor. I can't. The 3 and the 6 I could reduce, but I can't reduce it with the 10, and the same thing with the 10 and the 6. I could divide them by 2, but I can't divide the 3 by 2. Okay, if I look at C, my common denominator for C would be 24. So what would I multiply the first fraction by? And the second fraction? So this time when I go to remove my brackets, because I'm subtracting, think of this as being a negative 8. And then that way all the brackets would disappear. So I'd have 24y minus 9 minus 16y minus 8. So then I collect my like terms. 24y's minus 16y's. And negative 9 minus 8. Negative 17. And again, if I look at trying to reduce it, the 24 and the 8 have a common factor, but it's not common to 17. What do you notice about class example 3 compared to class example number 2? Yeah, I have something here that's not a fraction. Can I make it a fraction? What do I do? Exactly. So now I have my denominators, 2, 1, and 8. So my common denominator would then be 8. So what would I multiply the first expression by? Okay. And the second expression? 8. And the last expression? Just leave it. So because it's a subtraction, I am going to include a set of brackets around that x minus 3. So now in the second step, when I go to remove my brackets, 28x plus 12 plus 24x, and then I get a minus x and a positive 3. So 28x plus 24x minus 1x. And 12 plus 3? And it's all over 8. Okay? So I'm going to give you a couple of minutes. I want you to try to do question B on your own. So what's my common denominator? 9. So what do I multiply 4 by? 9. And I would get 36. And then this y minus 4 I would leave, but I am going to put it in brackets. And then what do I multiply the last expression by? 3. So I get 36 minus y plus 4 minus 15 plus 9y. And what does that simplify to when I collect my like terms? How many y's do I have? 8. And then 36 plus 4 minus 15? Okay, so I want you to work on question 2C and 3B. I'll give you a couple of minutes for that. So in the next part, we look at what happens if my denominators are not rational numbers. What happens if they're actual expressions? So the first thing that we'll look at is common denominators. If everything is the same denominator, I can put everything over x and then just combine the numerators. 2 plus 7 minus 1 would equal 8. So I would get 8 over x. But because now I have variables in the denominator, I have to think of those non-permissible values, those restrictions. So what value can't x ever equal? 0. Why? Because you can't divide by 0. So now if we look at B, denominators are common, so I can combine the numerators. 5a plus 3. This being an addition, I can just combine. So 5a plus a would be 6a, and then 3 minus 6. So again, I check to see if all 3 terms have a common factor, which they don't. So this is simplified. Now I need my non-permissible value, my restriction. So what can't a equal? 0. So remember, to find that restriction, I can let the denominator equal 0 and then solve for a. So if 2a equals 0, divide by 2, a equals 0. So B is a bit different, or sorry, C is a bit different in that I'm subtracting. So I get 3y minus 1 over 3y minus 1. What is that going to equal? It'll equal 1. But I have a restriction, because I have a denominator in my original expression. So what can't y equal? 1/3. So even though the answer equals 1, and it equals a rational number, not an expression, I still have to put in that y can't equal 1/3. And then with D, at 4x plus 10, when I subtract this, I'm going to get a negative 2x and a negative 4, because I'm subtracting both terms. So if I go to subtract this, 4x minus 2x would be? 2x. And 6 minus 4? Or sorry, 10 minus 4?
Equals 6.
Equals 6. If you take a look at the numerator, what do you notice? Choose a common factor on the numerator. When I remove that 2 as the common factor, what do I end up getting? Yeah, I get something that I can then cancel down here. So I end up with a final answer of 2. But what's my restriction? What can't x equal? Negative 3. So these questions have two parts to them. Not only do you actually have to solve by adding or subtracting, or simplify the equation, you always have to remember those non-reducible values. So now when we have different denominators, if I look at 3p and 7p, they both have a p in common, so they have to have a p in the common denominator. Now I look at the numbers. What's my common factor for 3 and 7? Or common multiple, I guess. 21. So 21p would become the common denominator. So how would I go from 3p to 21p? What would I multiply by? 7. So I multiply the top by 7. 7 times 5? What would I multiply the 2 by? 3. 2 times 3 is? So 35 plus 6? 41. So 41 over 21p. And what can't p equal? 0. Because if p equals 0, 21 times 0 would be 0. I can't divide by. Take a look at b. What would be my common denominator? It would be 15y. Your common denominator has to be something that if I then took the denominator and divided it by either one of these denominators, I would get a whole answer. I would get something that I wouldn't have a remainder or a repeating decimal or anything like that. So what can I multiply 3y by to get to 15y? So 5 times 1. And what would I multiply the 6 by? And 6 times 3y? I cannot combine the top because it's now an expression, and they have no common factor. These have a factor of 5, but it's not common to the 18. So it would be left like this. What can't y equal? 0. What's my common denominator for 6x and 3x? 6x, good. So 2y minus 5 would stay as is because the denominator didn't change. What would I have to multiply 3x minus 2 by? So again, think of it as being a negative 2. So I get negative 6x plus 4. So 2x minus 6x. Negative 4x. And negative 5 plus 4. There's no common factor that I can divide each term by. So this is simplified. I can't factor the top. So it's not like the situation we had up here where we could factor out a 2. What can't x equal? What's that? 0. Sorry, I just didn't hear you, Evan. It's not that it was wrong, I just didn't hear what you said. Okay, look at D. What do you think the common denominator would be? Why 10a squared? First of all, why the 10?
It's the common denominator, just 2.
Right? Okay, and why a squared and not a? You already have an a squared, and a is not a factor of a squared. Or sorry, yeah. A squared's not a factor of a. A is a factor of a squared. Meaning that I can go a squared divided by a, but I can't go a divided by a squared. Okay? So what would I multiply the first expression by to get to that common denominator? 5. And what do I multiply the second fraction by? 2a. So I'd have 5a plus 35 minus 6a over 10a squared. So if I simplify the top, what would I get? Yep. All over 10a squared. And what can't a equal? So is there a number that when I square it and then multiply the answer by 10, I get 0? 10a squared can't equal 0. So what would be my first step? And what's 0 divided by 10? 0. So now I have a squared equals 0. Then what would I do? Square root both sides. What's the square root of 0? 0. So a can't equal 0. So I want you to try questions 5, C, and E. Okay, the last part looks at adding or subtracting rational expressions which have monomial or binomial denominators that do not have a common factor. So even with what we were doing at the bottom of the previous page, there was still a common factor. These ones both had a p in common or an x in common. what happens if they don't have anything in common? So this is the same as the question, what happens if I have thirds and fifths? How do I find the common denominator? Multiply them together. So if they don't have any common factors, my common denominator I obtain by multiplying them together. Now when we multiply them together, there's two things. So the first thing, we leave the denominator always in factored form. We simplify the top, but we leave this in factored form because what do we have to indicate? Non-permissible values. And they are far easier to indicate in factored form than if we expand it. Because really, if we have to expand it, we're going back to the factored form to find those non-permissibles anyways. So now if I look at the top, in order to go from this 2x, from this denominator to my new denominator, what would I have to multiply by? So I have to multiply the top by x minus 4. So I get x minus 4 times x minus 9. And what do I have to multiply the second expression by to get my common denominator?
2x.
So I have to multiply the 3x by 2x. So this is where if you can simplify some of this stuff in your head without having to go through all of the steps can save you some time and some space. So if I go to expand this out, I know if I multiply the first terms together, I'll get an x squared. Then I have this outside term, which is a negative 9x, and this inside, which is a negative 4x. So together I get negative 13x. And then the negative 9 times negative 4 would give me a positive 36. Add that to the 6x squared that I get when I've got 2x times 3x. And again, leaving my denominator in factored form. Next step, collect like terms. So I get 7x squared minus 13x plus 36 over 2x times x minus 4. And that's where it would stay. I wouldn't look at trying to, because there's not going to be a common factor to worry about trying to cancel anything out. If there was a common factor, I would have been able to deal with it up here. But because these two had no common factors, the numerator is not going to have a common factor. So again, now if I list my non-permissible values, what can't x equal? So I look at the 2x. When would 2x equal 0? If x equals 0. And then I look at the x minus 4. When would that equal 0? When x is equal to 4. So there are my two non-permissibles. So if we look at b, there's not a common factor between my two denominators. So my common denominator would be multiplying the two denominators together. So what would I multiply the first expression by to get my common denominator? Y minus 3. And because the top is a monomial, I'll put it in front because I'll probably find it easier to multiply it that way than to have the y minus 3 and the 4 at the back. And what would I multiply the second expression by?
2y plus 5.
So again, because this is a monomial, I'm going to treat it as a negative 1 times 2y plus 5. So then I collect my like terms, or sorry, not collect my like terms, I have to remove the brackets first. The subtraction questions are always a little bit trickier because of that subtraction sign. You have to make sure that your signs carry through in the second expression. And then this is all over that common denominator. So 4y minus 2y. And negative 12 minus 15.
It's just a minus 5, isn't it?
Or sorry, what did I say?
15 minus
So negative 12 minus 5 now would be
5.
negative 17. Kind of wondering why everybody was kind of very quiet. And then I have my non-permissibles. So what value of y would make 2y plus 5 equal to 0? Negative 5 halves, because I'd move the 5 over, it would become negative, and I'd divide by 2. I don't know why I put a 0 there. When does y minus 3 equal 0? When y is positive 3. So there are my two non-permissible values. Okay, so if we look at C, what's my common denominator? So what are you writing for a common denominator?
X minus 5.
So what would I have to multiply the 2x plus 1 by?
X plus 1.
And what would I multiply the x minus 4 by?
X minus 1.
X minus 5? Okay. So if I go to expand x plus 1 and 2x plus 1, I would get 2x squared, and then I'm going to have an x and a 2x, which would give me 3 x's, plus 1. And then when I expand out the x minus 5 times x minus 4, I'm going to throw in a set of brackets because I have to subtract what the product of this is. So I would get x squared minus 9x plus 20 so I start collecting my like terms. 2x squared minus x squared is x squared. 3x minus negative 9x. So that negative 9x would end up being plus, so 12x. And then 1 minus 20, negative 19. And what can't x equal? Okay. So let's push through question 7, and then I'll give you time to work on these questions at the beginning of class tomorrow. What's my common denominator going to be?
Is it x plus 2 and x plus 1?
Yes. The only thing I'm going to do is I'm going to put the x out in front just so that I don't lose it. So then what do I have to multiply the 3 by?
X plus 1 and x.
Yes. So again, I'm going to put that x out first. So I'm going to get a 3x times x plus 1. What do I have to multiply the 2 by?
X and x plus 2.
So when I write it, I'm going to put it as a negative 2x times x plus 2. And then what would I multiply the 1 by?
X plus 2 and x plus 1.
Right. So now if I remove my brackets, 3x squared plus 3x minus 2x squared minus 4. And because this is adding, so I'm adding all of this, I don't need to put brackets in there. It's only when I'm subtracting that I'd want the brackets in. So if I multiply this out, I will get x squared plus 3x plus 2 all over x times x plus 2 times x plus 1. Collect my like terms. 3x squared minus 2x squared plus x squared would be what?
Should that 4 in the middle be 4x?
Yes, it should be. Okay, so how many x squareds would I have?
2x squared.
Yes. How many x's would I have?
2x.
And then the 2? What do you notice about the top? I can factor out a 2. So in this case, I would do that just in case there was something on the bottom that I could cancel out. In this case, there isn't, but I should factor that. And what can't x equal?
0,
Good. Okay, I'll write down the questions that you will have, but you will have time to work on these. So 7, C and F, 8B, 9, 11, and 12.